Hello everyone. Today we will study applications of system of linear equations. This is my lecture number 6 on matrices. I would like to request to all of you to subscribe channel on engineering mathematics to get latest updates and videos on it. First we will see system of linear equations. We consider system a11x1 plus a12x2 and so on up to a1nxn is equal to b1, a21x1 plus a22x2 and so on up to a2nxn is equal to b2. In similar way, am1x1 plus am2x2 and so on up to amnxn is equal to bm. We can write this system in the matrix form as ax is equal to b, where A is called as a coefficient matrix, X is called as matrix of unknown, and B is called a right hand side. So, we'll see standard results on system of non-homogeneous equations, which is given by Ax is equal to B. So, we find rank of A as well as rank of augmented matrix AB, and if these two ranks are equal to n, means number of unknowns, then the system is consistent and has unique solution. If rank of A is equal to rank of AB is less than n, means number of unknowns, then system is consistent and has infinite many solutions. And if rank of A and rank of AB, they are not equal, then system is said to be inconsistent and has no solution. So, system of linear equations has many applications in various fields, including circuit analysis. So, today we'll see applications of system of linear equations and we'll see problem based on that. Problem number 1. Determine the current in the network given in figure below. So this is circuit diagram given to us and we have to find the current. So to solve this problem, we have to apply Kirchhoff law of electrical circuit. So applying Kirchhoff law, current law, as well as applying Kirchhoff voltage law. So if you apply Kirchhoff current law, so incoming currents are I1 and I3. So I1 plus I3, that is equal to outgoing current is I2. So I1 plus I3 is equal to I2. That means I1 minus I2 plus I3 is 0. So that is equation number 1. Now if you apply Kirchhoff voltage law for this particular loop, that says that voltage drop across any loop is equal to applied EMF. So we have, if we consider this upper loop, 40 I1 plus 30 I2 is equal to 20. And if we apply Kirchhoff law for lower loop, so it is 40 I3 plus 30 I2 is equal to 40. So this system can be written in the matrix form as AI is equal to B. So A is called as a matrix of the coefficients and we try to write augmented matrix AB. So here we can write this first equation as a first row. So it is 1 minus 1 1 and right hand side is 0. So this is right hand side. And second equation is we cancel 10 from this and we can write 4, then 3, then I3 is not there, means 0 is equal to 2. Here also we take 10 common and we can cancel. So we can write this as 0 because I1 coefficient is 0, I2 coefficient is 3 I3 coefficient is 4 and that is equal to 4. So first equation is 1 minus 1, 1, 0. First equation. Second equation is 4, 3, 0, 2, 0, 3, 4, 4. So that is augmented matrix AB. Means it is I1 minus I2 plus I3 is 0. This means 4I1 plus 3I2 is equal to 2. And this means 3 times I2 plus 4 times I3 is equal to 4. Now we find rank of matrix AB as well as A, and from that we will find the solution. So augmented matrix we write here as it is. Then we need to make this position 0. For that we perform operation R2 minus 4R1. We are trying to reduce this matrix to its echelon form. Means we are trying to make every entry below diagonal as 0. Means we have to make this entry 0 as well as this entry 0. So for that we perform operation R2 minus 4R1. So R1 remains as it is 1 minus 1, 1, 0. Then R3 also as it is 0, 3, 4, 4. Then R2 minus 4R1. So it is 4 minus 4 is 0. Then 3 minus of minus 4 means 3 plus 4 is 7. Then it is 0 minus 4 means minus 4. 2 minus 0 that is 2. So we get this. Now next part is we have to make this position 0. We have to make this position 1. So for that we have 1 minus 1, 1, 0. First row as it is. We want below this diagonal entry as 0. So we make this position 0. For that we perform operation. Means here we multiplied by 3 and here we multiplied by 7. So we get 21 minus 21 as 0. So we perform operation 7R3 minus 3R2. So row number 1 as it is 1 minus 1, 1, 0. Row number 2 also as it is 0, 7 minus 4, 2. Then third row become 0. Then this is obviously 0. Then you perform operation 7R3. Means it is 7 into 7R3. 7 into 4, 28. And minus 3R2 means 3 into 4, 12. So that gives 40. Then if you perform that operation for this element, 7R3 means it is 28 minus 3R2 means 3 into 2 minus 6. 28 minus 6 that gives 22. Now we can easily observe that below all diagonal entry every element is 0. So this form is echelon form of the matrix. And rank of matrix is number of non-zero rows in the echelon form. So here we have rank of A, if we cut this part, is 3 because there are 3 rows, all are non-zero. Also rank of AB is same, which is 3, and that is equal to number of unknowns. So we have got unknowns I1, I2 and I3. So system is consistent and has unique solution. How to get solution? As we know, every row is a equation. So what is the meaning of last row? We start from last row, bottom to top. So last row means it is 40 I3 is equal to 22. So that gives I3 is 22 by 40. Means it is 11 by 20. So I3 is 11 by 20. Then last but one row means 7 I2 minus 4 I3 is equal to 2. So I2 is, if we substitute here, simplify. So it is 2 plus 4 I3. So it is 1 by 7 of 2 plus 4 I3 means 11 by 20. So if we calculate this, that gives 4 by 20 means 5 So it is 21 by 5. And if you simplify this, it gives 3 by 5. So I2 value is 3 by 5. First row is I1 minus I2 plus I3 is 0. So I1 minus I2 plus I3 is 0. Put value of I3 and I2. So I1 is I2 minus I3. And I2 is 3 by 5. I3 is 11 by 20. If we simplify this value, we get 1 by 20. So I1 value is 1 by 20. So finally we have I1 current is 1 by 20, I2 is 3 by 5 and I3 is 11 by 20. So that is the final answer of this problem. So we take another problem. Yes, I1, I2 and I3 we have mentioned at the end. So another problem is problem number 2. To solve the following traffic problem, which is given in this particular diagram. So to solve this, again we have to apply Kirchhoff law. For that we consider this diagram, and traffic inflow at each junction is equal to traffic outflow. So if we consider A, at junction A, we have incoming current, that is 300 plus 200. So it is 200 plus 300. And outgoing are X1 and X4. So 200 plus 300 is equal to X1 plus X4. Means X1 plus X4 is 500. If you look at junction D, so here 400 plus 400 means 800 is equal to X1 plus X2. So X1 plus X2 is 800. If you look at junction C, at C, we have, it is 600 plus 500, which is equal to X2 plus X3. So X2 plus X3 is 1100. At junction B, we have 300 plus 500 means 300 plus 500 is equal to X3 and incoming current, X3 and X4. So X3 plus X4 is 800. So we can write this system in the matrix form as AX is equal to B, which can be written in the matrix form. We call it as augmented matrix. That is what? Here X1 coefficient is 1, X2 is not 0, X3 is not 0 means 1, 0, 0, 1. X4 is 1. And right hand side is 500. So every row is one equation. This can be written as 1, 1, 0, 0 and 800. Then this equation X2 means X1 coefficient is 0, X2 is 1, X3 is 1, X4 is 0. That is equal to 1100. And last equation 0, 0, 1, 1, 800. Now we find rank of augmented matrix AB as well as rank of A, and from that we decide solution of this system. So augmented matrix we write as it is. Now our next target is making this position 0. For that we use row operation R2 minus R1. So row number 1 as it is 1, 0, 1, 1, 500. Row number 2 will be this minus this means 0, 1, 0, then it is minus 1, then 800 minus 500 means 300. Row number 3 as it is 0, 1, 1, 0, 0, 1, 1, 1. Yes. And that is equal to 1100. Last row also 0, 0, 1, 1, 800 as it is. Now our next target is making this position 0. So for that we use operation R3 minus R2. So first row as it is, second row also as it is, and third row will be R3 minus R2 means 0, yes, 1 minus 1 is 0, then it is 1, then it is plus 1, 1100 minus 300 means 800, and obviously last row as it is 0, 0, 1, 1, 800. So we get this. Now we have to make this position 0. So we perform operation R4 minus R3. So in that case, row number 1 as it is, row number 2 as it is in previous step, row number 3 also as it is, and row number 4, because R3 and R4 are identical and we are subtracting R3 element from R4. So that's why we are getting last row as 0. So we got echelon form because below diagonal entry every element is 0. So we find rank of A. Rank of A is obviously 3 and rank of AB is also 3. So system is consistent and that rank is less than 4. There are 4 unknowns, I1, I2, I3 and I4. So rank of A is 3, rank of AB is also 3, that is less than 4, which is number of unknowns. So therefore system has infinite many solutions and those solutions can be obtained just by considering every row as one equation in the last. So last row is not useful. Last but one row means it is I3 plus I4 is 800. And in such case, we assume last variable generally as t. So we take x4 as t and we get x3 as 800 minus t. Then last but one means second row is x3. Yes, x2 minus x4 is 300 and x4 is t. So we get x2 as 300 plus t. And first row means x1 plus x4 is 500. That means x1 is 500 minus t because x4 is t. So solution of given system is x1 as 500 minus t, x2 as 300 plus t, then x3 as 800 minus t and x4 as t. So that is our final answer. We take one more problem. Determine the current in the network given in the figure as shown in this diagram. Okay. So to solve this problem, again we apply Kirchhoff law, and if we apply Kirchhoff law for this particular junction, so we have 1, we can say. So here incoming currents are I3 and I1. So I1 plus I3 and outgoing is I2. So I1 plus I3 is I2. That means I1 minus I2 plus I3 is 0. Now if you apply voltage law for this particular loop, upper loop I can say. So for this loop we have 3I1 plus 2I2 is applied EMF is 7. So 3I1 plus 2I2 is 7. And if you apply Kirchhoff law for lower loop, we have 2I2 plus 4I3 is equal to applied EMF is 8. So 2I2 plus 4I3 is 8. As 2 is common, we can write this as I2 plus 2I3 is equal to 4. So we can obviously write this particular system, which consists of 3 equations, 3 unknown, in the matrix form as AI is equal to B. So we can write it in this form. Augmented matrix AB is 1 minus 1, 1. Yes, 1 minus 1, 1. Right hand side is 0. Then second equation means 3, 2, 0. I3 is not 0. Is equal to 7. And last row means, last equation means last row. So I1 is not there, means 0, 1, 2, 4. So it is 1 minus 1, 0, 3, 2, 0, 7, 0, 1, 2, 4. We find rank of this matrix. For that, we try to make every entry below diagonal as 0. So, we have to make this position 0 as well as this position 0. So, we first make this position 0. For that, we perform operation R2 minus 3R1. So, in this case, row number 1 as it is, row number 3 as it is. What are changes in row number 2? Just perform this operation. R2 minus 3R1 means 3 minus 3 is 0. Then it is 2 plus 3 is 5. Then it is 0 minus 3 means minus 3. And 7 minus 0, that gives 7. So we get this. Now next target is we have to make this position 1 and here 0. So that's why we interchange row number 2 and 3. So that's why operation is R2, 3. So row number 1 as it is 1 minus 1, 1, 0. Row number 2 will be row number 3 now. So it is 0, 1, 2, 4. And row number 3 will be row number 2 from this. So it is 0, 5 minus 3, 7. Now we want this position 0. For that, we perform operation R3 minus 5R2. So row number 1, row number 2 as it is from previous step, and this row becomes 0 as it is. 5 minus 5 is 0. Then it is R3 is 3 minus 10 is minus 13. Then it is 7 minus 20. That gives minus, yes, it is 13. Okay, 7 minus 20. So it is 13. So here rank of A is equal to rank of AB is 3. So that is equal to number of unknown. The system has unique solution. So we have, actually this is minus 30 because 7 minus, yes, 7 minus, what is it? It is 20, means it is minus 30. Actually there is typing mistake over here. So minus 13 I3 is equal to minus 30. So I3 is 1 if you solve last equation. Then we have I2 plus 2I3 is 4 and I3 is 1. So I2 is 4 minus 2I3 and 4 minus 2 is 2. So I2 is 2. Then first row is I1 minus I2 plus I3 is 0. So I1 minus I2 plus I3 is 0. But I3 is 1, I2 is 2. So I1 is I2 minus I3. So that is I2 means 2 minus 1. So it is 1. So final answer, I1 is 1, I2 is 2 and I3 is 1. So in this way you can do more practice of solving such type of examples and you can get mastery over the problems of such type. Okay. So I wish you all the best, happy learning, and thanking you for listening patiently this particular video and wishing you all the best. Thank you.